AR or Augmented Reality. AR adds digital content onto a live camera feed, making that digital content look as if it is a part of the physical world around you. AR system comprises three components: hardware, software, application. First is hardware. The hardware refers to your equipment through which the virtual images are projected, for example, smartphone. Here are some of key hardware components. First is processors. This is the brain of the device. It determines the speed of your phone and whether it is able to manage the heavy AR requirements, in addition to its normal phone function. Second is Graphic Processing Unit or GPU. The GPU handles the visual rendering of a phone display. AR requires high-performance GPU so that the digital content can be created and superimposed seamlessly. Third is sensors. This is the component that gives your device the ability to make sense of its environment. Common sensors required for AR include light sensors to measure light intensity and brightness, gyroscope to detect the angle and position of your phone, proximity sensors to measure how close and far something is, depth sensors to measure depth and distance, accelerometer to detect changes in velocity, movement, and rotation. Second component is software.
This is where the AR magic begins. Arcade for Apple and AR Core for Android are some examples of AR software. These programs have three fundamental technologies that enable them to build augmented reality experience.
First is environment understanding. This allows your phone to detect prominent features, points, and flat surfaces to map its surroundings out. In doing so, the system can then place virtual objects accurately on these surfaces. Light estimation. This gives your phone the ability to perceive the environment's current lighting condition. Virtual objects can then be placed in the same lighting conditions to enhance realism. Motion tracking. This lets your phone determine its position relative to its environment. Virtual objects can then be planted on their designated spots on the image. Third component is application.
It is important to be clear that the software allows AR applications to run on your smartphone, but doesn't praise the AR features. The AR features such as 3D objects and filters come from the mobile applications themselves.
Applications such as Pokemon Go, Instagram.
Working principles of AR.
There are generally two ways that application triggers AR features. First is marker-based tracking and markerless tracking. Marker-based tracking. This mode requires optical markers such as QR code to trigger the AR features by pointing your mobile camera at one of these barcodes. The application recognizes it and superimposes the digital image on the screen. Markerless tracking. This mode is premised on object recognition. AR applications that work based on markerless tracking are triggered when they recognize certain real-world features. In the case of Snapchat, the real-world object is your face. So, now that you know the meaning of AR,
how does AR work?
First, get image from camera, computer vision, then rendering, and we got AR experience. Computer vision. Computer vision allows it to show digital content relevant to what the user is looking at. This digital content is then displayed in a realistic way so that it looks part of the real world. This is called rendering.
Computer vision processes the raw image from the camera and recognizes the receiver box. The rendering module augments the original frame with the AR game, making sure it precisely overlaps with the receiver box. For this is used the 3D positions and orientation of the box determined by computer vision. Why does AR need computer vision? While our brain is extremely good at understanding image, this remains a very difficult problem for computers. Augmented realities require understanding the world around the users in terms of both semantics and 3D geometry. Semantics answer the what questions. For example, recognizing the cereal box or that their face in the image. Geometry answers the where questions and infer where the cereal box or the face on the 3D world and which way they are faced.
Semantics and geometry of the world. In the semantic side, we have seen much progress thanks to deep learning, which typically figure out what is in an image without worrying about its 3D geometries, which builds on concepts from projective geometry. In the cereal box example, we need to know its position and orientation with respect to the camera to encode the AR game correctly when we display it.
How does AR display digital content? AR system, upon recognition, the rendering module displays the relevant content onto the camera feed, the last step in the AR pipeline. AR works is to consider computer vision as inverse rendering. Intuitively, computer vision recognizes and understands the 3D world from a 2D image. There is a face and where it is in a 3D world.
Augmented reality devices, mobile devices, spatial AR devices, AR glasses, AR contact lens.